Thank you so much, Saverio, for this very nice introduction. So I will present some of the results on using the citizen science approach for monitoring air pollution from wood burning. That's part of this Nordic Path project. Let me see if it goes. Yes. So the goal of this Nordic Path was to investigate how technologies can facilitate processes of collaborative co-design of solutions towards shaping more livable, healthy, and smart urban environments. In the project, we tested in an urban living lab methodology our approach of these technologies on Aalborg, Gothenburg, Kristiansand, and Lappeenranta. So as you can see, Nordic cities. The Nordic Path model for citizens' participation was based on three main pillars. One is the environmental monitoring, engaging citizens using low-cost sensor technologies in monitoring air quality. For that, we used static sensors that were mounted at the citizens' houses, and also mobile measurements using sensors that were mounted on bikes. Then we also wanted to get the insights from the citizens, from the inhabitants of the city, and for that we used participatory public GIS surveys, and we were asking them to get insights on their perception of air quality, but also the perception on the policies that the city has in place. As I said, we were testing these two pillars, environmental monitoring and participatory planning, in the set of urban living labs. The project finishes now in 1.5 years. We are in the Ecuador, and the lessons learned and the success stories from this project will be transferred to other cities in order to promote this socio-technical learning. In the project, as I said, one of our pillars is the environmental monitoring, and our hypothesis was that the citizen-driven environmental monitoring can generate knowledge that enriches and can be combined with official technologies for health and legislative purposes. And here I will put an example of how we show that this is possible. This is the results in Kristiansand in Norway from the static sensors mounted at citizens' houses. Here, as in circles, you can see the reference stations. It's only 2 reference stations providing data. And here you see how many other sensors from citizens we are gathering. On the bottom, you see the official air quality model, and we can see that there are lack of data in some of the neighborhoods where many families live, and where they are using wood burning as main method for heating. And we could see how the levels were really high during some of the days during winter. This data was not well captured by the official stations and neither by the model. So by aggregating citizens' data with official measurements, we can help the city to get a much more hyper-local data that can help in their policies. We also used the sensors mounted on bikes, and this is the data just from a couple of weeks ago. The winter is hitting hard in Norway, and here you can see again the same neighborhood where we gather the data, and again very high levels of PM 2.5 due to wood burning. Having this really hyper-local monitoring using sensors and this combination of static and mobile help us a lot of getting really much insights on the patterns. Here you can see it's one of the participants is cycling in the morning, and there is the air is clean. It's around 10, 11 in the morning. The air is clean, but when the same participants come back in the afternoon, the air is heavily polluted due to most probably to the use of wood burning for heating. We also engage with the citizens, not only monitoring, but also in this co-creation of some potential solutions for these problems on heating. And together with the municipality, we ask them how do they want to spend their budget for reducing air pollution, the municipal budget for reducing air pollution from household heating. And the municipality put here some of the ideas and they have on the table, but also they ask citizens for their own suggestions. Thanks to this questionnaire, we learned what were the preferred methods that were like change the stoves for more ecological or newer ones. Also improve the insulation from the houses. But also we learned that the main factor for using wood burning as a method for heating was because of the economy. It's a really cheap method. So that helped the municipality to know that while wood burning is so cheap, it would be really, really hard to change how the cities, how the houses are heated. And now we are working on co-creation of how we should address the increase in the bills from electricity if we change the methods. We gave back all the information from collected using the sensors and collected using the surveys to the citizens, so they are also like aware of the results. So we are using here also infographics to digest all the information and make it easier and combine their insights with actual facts from science. We in order to ignite this action among citizens and work together, municipalities, citizens, and businesses to address these problems, urban problems. We have worked in workshops where we invite the citizens and bring scientists and experts and businesses, so and the authorities. So then we create these areas for dialogue where everybody can raise questions and get answers and contribute with their ideas. But also we COVID-19 permitting, when possible, we brought the dialogue to the streets. And now in March, we will have a pizza gathering in one of the neighborhoods that is more affected by wood burning pollution, together with them to look for solutions for that neighborhood, so that citizens can still not be concerned about the economy of their household, and also improve air quality. This is a project in the Nordic cities where we are collaborating with different institutes in Sweden, Denmark, and Finland. Thank you very much.
Thank you, Nuria. And let me check if there are questions. Let's see. So currently I don't see it.
It is question here, yeah?
Okay.
Yeah. Okay.
Yeah, I see here. What kind of public measures do you think that are needed to tackle the situation? Yes. So here is there is a problems of governance and different governance levels, right? Because the city can, for example, have this ban on wood burning, but this is not possible for the city to choose that themselves. It needs to be at a national level. So what the city is doing right now, it has its partnershiping with fire brigade in order to deliver better instructions to the citizens on how to fire the stove, so that it produces less emissions, and also on the importance of cleaning their stove. And they will also partnership with the wood sellers, also as a way of having this information distributed when they are selling wood, so that in order to have at least these better instructions to the citizens, better knowledge. And then they are also now, we will have this workshop with also architects, and look for better insulation in the households, better insulation solutions, so that they do not need so much warming, but they are more efficient.
I have two questions personally. One is about the data simulation approach you follow, and how large the area that are subjected to monitoring are. And then if you think that this approach can promote environmental justice in our city. That's my question.
From the environmental justice, I think so, right? Like, because we see that one of the challenges is like the trustability in the data, right? So you collect the data with the sensors, and even if you apply calibration algorithms, it's still this lack of trust in the data. So by assimilating this data with already like other observations and official models, I think we can help to increase trust, right? Like, so that goes a little bit hand by hand. Also, like this type of data simulation, they help us to provide data in areas where we are not monitoring, right? Like, but I guess like the most important part is like the increase in trust of this data, no? And this capacity building on how to use this data if we want to have this environmental justice, right? And
thank you so much.
Yes.
And now the third and last presentation of this session, it will be given by Dr. Iveta Steinberg. She is a professor at the University of Latvia in the Faculty of Geography and Earth Science. She's leading the modeling laboratory of environmental processes. And her research area now are in modeling and environmental pollution, and processes in the atmosphere and the ecosystems, and also, of course, the assessment of particulate matter solution. And her contribution today is about the potential for using low-cost sensors measurement in outdoor environmental quality particulate matter measurement. So please welcome Dr. Steinberg, and Iveta, the floor is yours.
Excuse me, Saverio, we have one more question.
Sorry.
Two more questions, please. It is
sorry,
Rock Novak and Pierluigi.
No. Hi, Rock and Pierluigi. Please.
So it's for me or for question?
No, for the question for Nuria, I think. I understood that it was Rock Novak and Pierluigi Barbieri.
This was a question for Professor Castell.
Yes.
I missed the previous part, but the question is if she can provide maybe an example of an urban living lab, because there were several mentions, and I would just like to know a good example, because we're doing something similar in Ljubljana in the next year.
Yeah, thank you so much. Well, we have this urban living lab, like the Christian Sun, the one I was showing, where we first did a call of their bikes, and then we did these co-creation workshops where we put together scientists, businesses, and municipalities. This was around the topic of wood burning. Then the city of Gothenburg, also a partner in the project, they are working on the topic of parks. And how parks contribute to better livability and reduction of air quality. Then we have the city of Aalborg in Denmark, where their urban living lab is tackling also mobility, and they are working with a community that it's affected by an urban plan where they want to have a very large road passing through their neighborhood. So there is a confrontation between the necessity of this big road. So these are like the urban living labs we are working, and the urban living lab in Finland is very, very similar to the one in Kristiansand, as both of them. I'm not sure if I'm answering your question, but you can send me an email and we can talk some details if you want to.
Yes. Let's proceed to the last question that was from Pierluigi Barbieri, and then let's give the floor to Yvette again.
Sorry.
Pierluigi?
Just a question of the time you average data. I mean, one of the issue of comparing or providing information from citizen science, at least in my experience, is the issue of having very short scale measurements that can be very high, but when you average and you have a completely different situation. And how do you build this in communication? Because they are scared if for 30 seconds you have a very, very high value, and then when you average in 1 hour or in say 24 hours as the official data are provided, you have a totally different picture. So the issue of a time scale in communicating and in reading, say, environmental pictures and
Yes, I understand what you mean. Yeah, so we have two different type of sensors. So in the one that is static, the things are simple, right? Like because we just we have hourly averages of the data, and then they are on the same location, so we can have like from those daily averages or monthly averages. So it's more directly comparable with the regulations and legislations. In the case of the bikes, we have 1 minute measurements, and what we aim to do is that we provide the always the real time data to the citizens. So it's 1 minute measurements they can see, so they can easily then identify where they were in that moment, no? If they were behind a truck, and then they can understand, or if they were in certain neighborhoods or trespassing certain areas. But at the end, what partial average, let's say, like that will mean like all the measurements that were taken in a particular location, they will be average. With that, we aim to create a special map of air pollution where the hot spots and the cold spots are highlighted.
Thank you.